Today we're beginning Unit 5, and our first lesson is on ratios and proportions. So a ratio is a comparison of two quantities by division. You can write the ratio of the numbers a and b, where b does not equal 0, in three different ways. The first way is a statement that you would write a to b. The second way, a with a colon symbol, a to b. And the third way is a fraction, which is the most common way that I write a ratio. I write it as a over b or a to b. So I just used the letters a and b for explaining purposes, but typically you would have numbers or an amount, something that makes more sense in the form of a ratio. If we look down at the first example, I have two groups of students. So the first group, this group here, we're going to say that this is a group of girls. And just to save us time so we don't have to count every time, you can see there that the total is 5. So there's 5 students that are girls. This group here, boys, there are 15 total boys. All right, if we are asked to rate the ratio of girls to boys, that means we're writing in the form of the number of girls first, the number of boys second. So we could write that as 5 to 15. But again, my most common way, or the most common way I'm going to write it, is 5 over 15 as a ratio, which 5 over 15 is going to simplify to 1 over 3. And you always want to simplify, so simplify when possible. Boys to girls would be 15 over 5. The number of boys comes first. 15 over 5 simplifies to 3 over 1. That's telling us for every 3 boys, there's 1 girl. Girls to the total number of students. Well, the total number of students would be 15 plus 5, which is 20. In this case, girls would be 5 to the total number of students, which is 20. 5 over 20 simplifies to 1 over 4. For every 1 girl, there's 4 students total. And boys to total number of students, that would be 15 to 20. That simplifies to 3 over 4. That means for every 3 boys, there's 4 students total. These are ratios all written as fractions. Remember that you can change the way. You could write them multiple different ways. Number 2 says, at North Kingstown High School, there were 190 teachers and 2,650 students. What is an approximate student-to-teacher ratio at our school? If I look at the statement here, it's student to teacher. So that would be A to B. That means we want the student value first, the teacher value second. I'm going to write my ratio as 2,650 divided by 190. That's 2,650 students to 190 teachers. We can simplify this. This simplifies to, my first step for simplifying is 265 over 19. If I was to calculate this out, this is approximately 14. So it comes out to about 13.95 if I was to divide that in a calculator. So I could write a statement that says there are approximately 14 students for every 1 teacher. So again, divide that number out, 14, it would be 14 over 1, approximately. A little less than 14, but that's our approximate answer. The exact answer would be this. However, it just doesn't sound very nice to say. For every 265 students, there are 19 teachers. This sounds much better. So an extended ratio can be used to compare 3 or more quantities. You can see I used the notation A to B to C. So I could give you a basic example. We could say, let's compare the quantities of apples to oranges to pears. That's 3 separate quantities. Moving on to proportions. So an equation that states that two ratios are equal is called a proportion. In a proportion, the product of the extremes equals the product of the means. So I'm going to have you use cross multiplication for this, and we can say if A over B is equal to C over D, then you can multiply by cross multiplying your A and D value, and you can multiply your B and C value. You can't have 0 as your denominator, so I'm just going to write a quick note that says when B doesn't equal 0 or D doesn't equal 0, then A times D, that's what I circled in orange, is equal to B times C. And we find that from cross multiplication. If I give you a real example, we could say 4 over 10 is equal to 6 over 15. Four times 15 is going to give you 60. And we're going to set this equal to, when we cross multiply, 10 times 6, which is going to be 60. So we end up with 60 equals 60. And that's a basic example to prove that cross multiplication does work. Moving on to the next example set, I'm going to do out number 1 and 2 while I explain them, and then 3 and 4, please just follow along as I complete the answer. So number 1, we have 6 over x is equal to 5 over 4. So we're going to multiply 6 and 4, and then we are going to multiply x and 5. When I multiply these together, I have 6 times 4 is equal to 5 times x, or x times 5. This gives me 24 is equal to 5x. I'm solving for x, so I'm going to divide both sides by 5. And I'm actually going to leave this as a fraction, that way I don't even need to type it into the calculator. I'm going to say x is equal to 24 over 5. For number 2, y plus 4 over 9 is equal to y over 3. We have multiple variables here. We're going to multiply y plus 4 times 3. I'm going to write this using the distributive property because we're multiplying the 3 by both terms, so 3 times y plus 4 in parentheses, and this is equal to 9 times y. This right here is super important. That's one of the most common things students forget is that they only multiply the 3 by one of the terms. You need to make sure you multiply the 3 by both terms in the parentheses. So we have 3 times y, and we have 3 times 4. 3 times y gives us 3y. 3 times 4 is 12. This is equal to 9y. I'm going to subtract 3y from both sides. 12 is equal to 6y. I'm going to divide both terms by 6. 12 divided by 6 leaves you with a solution of 2. Therefore, your y variable is equal to 2. Okay, and please follow along as I complete 3 and 4. And for the last example on this note sheet, we're going to use the cross product property to solve a real world problem. And the first one, or the only one, says that Gus conducted a survey of 50 students driving to school and found that 28 owned cars. If 755 students drive to school, predict the number of students who own cars. So I'm going to set up a ratio, and I'm going to set up the ratio of number of students who own cars over the number of students driving. So in his survey, it says he conducted a survey of 50 students driving, and he found that 28 owned cars. I'm going to set my first ratio up as the number of students who own cars. In Gus's survey, that was 28, divided by the number of students driving, and in his survey, that was 50. My second ratio that I'm trying to solve for is saying that 755 students drive to school. So we're trying to figure out how many of them actually own their car. We're going to use X to predict the number of students who own the car. And we know that 755 of them are driving. So when we cross multiply, we multiply 28 times 755. That's going to give us 21,140. And we're going to multiply 50 times X. That's going to give us 50X. I'm going to divide both sides by 50. And my solution is X is approximately 422.8. So I'm going to round that up to approximately 423. And then from there, I can just make a statement that says of the 755 students who drive to school, approximately 423 of them own their car.